Alright, so for the first part, we want everyone to have a look at 2 to the power of 5. Now, let's have a look at how can I write 2 to the power of 5 in the expanded form. Could you write that down in your worksheet, please? Okay, now I want you to tell me what did you write over there. Okay. 2 times 2 times 2 times 2 times 2. What does 5 mean here? In year 8, we have learned that. 5 means 5 lots of 2 are multiplying. Very good. Okay, we need to remind you again. 5 means 5 lots of 2 are multiplying. Okay, now for 2, we give that a 9. Alright, so 2 is called the base. Okay, 2 is called the base. And then 5 is called power, or index, or exponent. Alright, exponent. 3 names, it doesn't matter. Okay, so you use power. That is 5 lots of the base multiplying. That is basically the meaning. Okay? Alright, good. Now, we want you to quickly write down what does 2 to the power of 2 mean. 2 is the base, and then the 2 is the power. That one will be easier. What is 2 to the power of 2? 2 lots of 2 multiplying. Very good. So that is 2 times 2. Okay. Now, let's quickly have a look at the expanded form if I times them together. Okay, if I times them together. 2 to the power of 5 times 2 to the power of 2. So, how can I write the expanded form? Could you write that down in your worksheet? Alright, so what do I have to write in my first bracket? Okay, so this is 2 to the power of 5. How about the second bracket? Very good, 2 times 2. So I just copy down the expanded form here. And also everyone, in order to do this, in order to make that clear, I put the bracket here. Now, does it matter if I get rid of this bracket? Does it matter? No, because they're all multiplications. Very good. So, how many 2's here? 7. Alright, so, but I want you to tell me, how did you get 7? Because you have 5 at the beginning, and then you have 2 later. So, you have 5 plus 2, lots of 2 multiplying. Does that make sense? Okay, so your answer is 2 to the power of 7. Good. Okay, now for this calculation, we can see you have 5 lots of 2. You can write that. You have 2 lots of 2. That's fine. You can write that. It's not very long. Now, how about this question? I give you 10 to the power of 25. Can you write that in the expanded form? Yes. Now I want you to write that into the expanded form. Write that down. You should not go over the line. You have to write everything inside the line. Alright, this is my writing. Have a look at my writing here. Alright, 10 times 10, and I do not write lots of 10 times 10, and I write 25 lots of. Okay? Now, could you please continue to follow my style of writing and continue 10 to the power of 35. How can I write that into the expanded form? So how can I write 10 to the power of 35?
10 times 10.
And then?
Times 10.
Okay. So that means I started from 10 and I show one calculation and the rest is the same until I get the last one. Okay, good. How many? 35. Good. Okay, very good. So that is another way to express something. So 25 lots of and 35 lots of. Okay. Now, how many 10 do you have?
16.
How do you get 16? 25 plus 35. You add them together, is that correct? Okay, so we do 25 plus 35. That is the answer. So 10 to the power of 60. Now you nearly get that. That's very good. Okay, so that is for the number. If we have the number to the power of 25 to the some power, and then you know how to express that if you have a lot. Alright, you cannot fit into this small space. This is the way you can use, okay, in the future. Okay, now we finish all the number. Alright, we finish all the number. For numbers, now you know how to do the calculation. How about the pernumerals? Now I can say the base can be 2, can be 10, the base can be 25, the base can be negative. So I want to use the general writing to express that. Okay, so let's have a look. If I have a to the power of 3 times a to the power of 2. Now I would like you to write the expanded form and then the index form. Now please think a is a number. It's nothing different. Okay? If it has 10, that's 25 lots of 10. If that's a, that is how many a? So you have a times a. Okay, now for the first one you have a to the power of 3, that means 3 lots of a are multiplying. For the second part is 2 lots of a multiplying. How many a in total? 5. Good, so that's a to the power of 5. Actually, you do the addition. 2 plus 3. You plus the number of a. Okay. Now the last one, well, let's have a look at if I have the power of m. How can we do that? Now, I'll give you some hint. Just now I showed you how to write 25. Okay, it's a lot. How can I express 5 to the power of m? 2 to the power of 2, that means 2 lots of 2 multiplying. 2 to the power of 5 means 5 lots of 2 are multiplying. 10 to the power of 25, that means 25 lots of 10 are multiplying. How about 5 to the power of m? How many 5? M lots of 5 are multiplying. Good, so write that down. Please express that. Yes. How can I express m lots of 5? So we have 5, 5. We can use multiplication sign, that's fine because it's a number. How many 5? M also. you have n lots of 5. Good. Okay. Now just now I said m to the 5 to the power of m is m lots of 5 are multiplying. So multiplying. How many 5? M lots of. Okay. How about the next part? What can I write? And lots of. So equals. Hey, some people say mn. I heard about that.
M plus n.
M plus n or mn. Think about this. 5 and 2. What did you do? Plus. 25, 35. You plus them. So for here, that should be m plus n. Okay, so this is the way we express the number of 5. M and n, totally n plus n lots of. Okay, now let's go into the rule. Right, let's plot the rules here. Okay, so I use a to represent a number or a term. It doesn't matter what. And then m and n is the power. So for this one, very good. So you've got that a times a. How many a? M lots of a. Good. Okay, m lots of a. Multiply. Now, how about a to the power of n? A dollar. Right? Okay? You have n lots of a. So, totally, how many a do you have? You have m lots of, and then you have n lots of. Totally, m plus n lots of. Very good. So, if you have m plus n lots of a, what can I express in the index form? A to the power of m plus n. Good. Okay, so this is the multiplying powers law. Okay? Okay, the multiplying powers law is, now let's have a look at this. A to the power of n times a to the power of n equals a to the power of n plus n. How can I express that in word or in a sentence? I start with when. When multiplying, applying what? To pernumerous, but is that restricted to 2? Can I multiply 3 terms? Yes. 4 terms? Yes. Yeah, terms. Very good. When multiplying terms, what do I have to do? What did you do? Add the powers. Good. Does everyone agree with this conclusion? When multiplying terms, add the powers. Same what? Very good. You can see. I really need that. This is the next I want to say. I'm waiting for everyone to say yes. And then I can say, okay, let's have a look at this question. I'm very naughty, right? So 2 to the power 3 times 3 to the power 5. Is that 6 to the power of 11? Okay? You cannot use the law for this one. You cannot use the law. Now, you may notice the common thing we use is 2 times 2 is 10 times 10, 8 times 8, 5 times 5. Good. So this is very important. When multiplying terms with the same base, add the powers and keep the base unchanged. Okay? We do not change the base because you always use the base to do the multiplying. You do not change the base. So base is not changed. Okay, now, do you think you still want to add something? Is that everything here? Yes. Okay, good. So when multiplying terms with the same base, and then you add the power. Very good. Now, for this one, I really want to use my way to tell you how to remember that. Now, I taught my class last year. I really want to share this idea with you. Now, we want everyone to write this. Okay, so when we do multiplication, and then I want you to draw this. That means the lower level is addition. Add the power. Right, add the power. Okay, what's that? I explain that to you. When you multiply two terms, for the power you need to do lower level of calculation. Now, multiplication, division, and addition and subtraction, which two have the priority to do? Division, according to the back math. Multiplication, division, you have to do that first, followed by addition and subtraction. Okay? So, this is the hierarchy. I talked to my students last year. You need to remember this hierarchy in math. Good, now remember this hierarchy. So when you do multiplication for the power, you do the lower level of operation. And then you can remember that. Okay? So I'm going to explore that more in the future. Okay, now let's have a look at some examples. For all the questions today, I don't want you to write the expanded form. Like I said, sometimes it's impossible, like this. Alright, it's impossible you write 35 or 25 lots of 10. So I'm going to show you how to write. Your writing is very important, that is your communication. The first one is very easy, x to the power of 2 times x to the power of 5. Okay. Now, before you start doing all the questions, we want you to double check two things. First thing, please check, do they have the same base? Same base? Yes, they're all x. Number 2, are they multiplication? If addition, you cannot follow that. Okay? X to the power of 2 times x to the power of 5, is that multiplication? Yeah. Yes. So, you can use the law. The law is a to the power of m plus n. So, keep the base unchanged, plus the top, plus the index. So the answer is x to the power of 7. Okay? Alright, now we want you to do this example by yourself. So a times a to the power of 6 times a to the power of 3. Now, okay, now let's have a look at this question. A to the power of a times a to the power of 6 times a to the power of 8. Good. Alright, so tell me which one plus which one plus.
I did 6 plus 8 plus 1.
Oh, she did
I did that too.
6 plus 8 plus 1. Where does 1 come from? My thinking is
Comes from the
6 plus 8 plus 0. It's nothing here, so that's 0.
As soon as no, because it just makes 8 and have 1.
unspoken.
Yeah, 8. Then it wouldn't be an answer.
Very good. Alright? Okay. Now, this is the most important thing. If nothing, that's why I said nothing does not mean 0. Okay? So, you've got a very good concept. A to the power of nothing, that means you have only one a here. So that's to the power of 1. Okay? Alright. So for this one, we said 6 plus 1 plus, 6 plus 8 plus 1. So the answer is a to the power of 15. Good. Okay, good. Now, how about question C? Now, could you do that by yourself? Negative 2 times negative 2 to the power of 4 times negative 2 to the power of 3. Now, write the procedure. Do not jump to the last step. You'll make mistakes. Could you tell me what procedure do I have to write? What do I have to write here? Negative 2. And then
1
1.
plus
Good.
4 plus 3
Plus 4.
plus 3.
Plus 3. Good. Okay. All right. So the answer is okay. Negative 2 to the power of 8. Okay. Now, if you have this answer, that's correct. But can I write like? Yeah. Okay.
Oh, no.
Okay.
It is
Oh,
not
it's not
negative.
negative.
Because the negative times
to
the
the power
negative
of
is positive,
positive is
and times
positive.
by the negative is a negative, yeah.
Now, if you have the even number of the power, are they the same? Yes. Okay? It's the same.
How?
Because a pair, you have, okay, positive. A pair, you have positive. And a pair, you have positive. So you have even number of negative 2. So the answer is equal to 2 to the power of 8. They have the same answer.
So if it was negative 2 to the power of 7, it would.
No.
Okay.
No. Okay? Alright, so for this question, I can accept both of the answer. Now, if you are not sure, you don't have to go the next step. Okay? So this step is correct. If you understand that, we want you to simplify that because this one will be easier for your calculation. Okay? So currently, you may not feel that is convenient. In the future, when we put all of the calculation together, you may feel that is very easy. Especially when you do logarithm in year 11. That is very important. Okay? Alright. Now, let's have a look at question D. Example 4. Alright, let's write down x to the power of n times x to the power of 3n plus 1. Okay, now you don't have the number as the power, but it's exactly the sign. What do I have to write for my index? M plus 3m plus 1. Okay, we just add, it doesn't matter what's on the index, just add them together. What is the answer? 4m plus 1. That's it. Okay? 4m plus 1. How about question F? Yeah, yes, question E. Some people say you cannot do that. For all of them, some people said you cannot do that whole part, of course, because for this part you have too many terms. For this time you have too many terms. But can we find some terms with the same base?
Yeah.
Yes, because they are all multiplication. So we can rearrange that into -2 times 5 times Can I swap the order?
Yeah, we can.
It doesn't matter because 4 times 3 equals 3 times 4. So it doesn't matter y to the power of 8 is here or y to the power of 3 is here because they are all multiplication. I can make some, rearrangement. Now, can we use the law?
Yeah.
Yes, partially. So -2 times 5 is -10. Alright, so just normal calculation. And we do x separately. Because x, we have the same base, and then that is multiplication. So for y, we have the same base and the same power. We add the power. Okay? Alright, so for the single term, you know how to do that. So if I put them together, you do whatever you can, put them together with the same base, and then you do the multiplication. Okay, so for F, now I don't think for F this question is very difficult. It looks difficult. Firstly, let's have a look. Do they have the same base?
They have.
Yes. Are they multiplying? So, keep the base unchanged. What do I do for the power?
2 plus 3 plus 5.
2 plus 3 plus 5. Okay, now I really want to finish this one. Okay. Oh, some people say they don't have the same base.
But f equal 2 power 3. But a equal 2.
Do they have the same base? No. Can I write them into the same base?
Yeah.
How?
2 times 2 power 3.
It's 2 to the power of 3, 8. Yes. You don't have the same base, you make the same base. Because 2 times 2 is 4, 4 times 2 is 8, so that's 2 to the power of 3.